All right. Yeah, I'm going to talk about my favorite subject, and that's Azure Functions and more specifically durable functions. So let's get started. My name is Mark Duiker. As I said, I'm from the Netherlands. I'm a lead Azure consultant for Xspirit. Although this is my last month at Xspirit, I'll be changing jobs next month. Still secret where I'm going to, but I will announce my new job with a nice pixel art in the coming 1 or 2 weeks. So more on that later. I'm a co-organizer of Serverless Days Amsterdam and also a Microsoft MVP. So today we are going to talk about workflows, and then mainly workflows in code, and more specifically durable functions, and how you can write orchestrations and how to deal with even multiple orchestrations. So let's first talk about the workflows themselves and then what are workflows. And if you look at the Wikipedia definition, it mentioned that a workflow consists of an orchestrated and repeatable pattern of activity. And so some very nice words, which also comes back in the durable functions naming, as talk about orchestration and individual activities and then a repeatable pattern. I think that's quite understandable. And I think developers over the years have used a lot of these workflows, albeit in different forms. So here's a visualization of a workflow that I've made for my Azure Functions update Twitter bot that will tweet whenever there's a new release related to Azure Functions on GitHub. And there are multiple steps involved. We read a bit of configuration from a table. We go to GitHub to pull some information from there. Also read some information from another releases table. I do a bit of comparison, and if a release is new, I post it to Twitter. And back in the days, something sometimes went wrong, and then I push it to queue stores. So this is just an example of a workflow, but every company has to deal with workflows and business processes to be automated. So this is probably is not new information. And then there has been a lot of different workflow management applications over the years as well. If you just look at Microsoft, there have been BizTalk for years and years. I actually looked it up, and the initial release was in 2000, so it's more than 20 years ago. But it's still being used. I think there was a recent release last year or this year still. I don't know, but it's still being used. Please don't, but it's still out there. So a lot of things got automated using BizTalk. The downside was that it was not really testable, all these workflows. One of the more newer things, and also very visually, is Azure Logic Apps. So you use a visual designer to create your workflow. And it offers hundreds of built-in connectors, so it's really easy to use. A little bit less testable still, although you can run Azure Logic Apps now also locally. So that's good for debugging, because under the hood, it actually uses the Azure Functions runtime. So that's interesting. And another one more geared towards business users is Power Automate, also known as Flow, I believe. More geared towards business users and automating your own maybe documentation. But today we'll be talking about a different workflow tool, and that's Durable Functions. So what is Durable Functions? So it is an extension on top of Azure Functions. And so it allows you to write your workflows as code. And it can be C# or it can be Python or JavaScript. And the nice thing about it is that the state of the workflow, of the orchestration that you write, that is captured to storage. By default, it's captured to a storage account. But these days there are also some different storage options. And because the state of the orchestration of the workflow is stored, it allows you to have really long-running workflows. Workflows can be hours, days, months. There's no limit to it. And it opens quite a lot of interesting possibilities, which is quite interesting for a serverless solution, because usually functions just run a couple of seconds and they time out in 5 or 10 minutes. But with durable functions, at least your orchestrations can run much longer. if we look at Durable Functions a bit under the hood, it's based on another framework. It's called the Durable Task Framework, and that's been in use within Azure by Microsoft already for many, many years. So even though Durable Functions is maybe relatively new, the base of it is already quite a bit older. So you could say it's proven technology already due to that. When you start working with Durable Functions, you'll notice that there are different function types or function roles. And you'll immediately see that there is an orchestration client function. And the responsibility of the client function is to manage the instance of an orchestrator. So from a client function, you can start a new instance of an orchestrator, but you can also terminate a running orchestrator from a client function, or you can raise an event from a client to an orchestrator. So there are a lot of things you can do with a client function. Then there is the orchestrator function. So that contains the logic of the sequence of the steps that will be executed. And the steps which are executed, those are called activity functions. So that's the smallest unit of work that is available. And these smallest units should only do one thing, like post something to an HTTP endpoint or get some information from a database. It should be really small and also repeatable. That's the best thing. So if you look back at our sample of the Azure Functions updates Twitter bot, where are then the client function, and where is the orchestrator, and where are the activities? Well, in this case, this whole process starts with a timer trigger function. So that's our client. Then this client starts an orchestrator function, but that orchestrator function is in this case the whole grouping of all the individual activities. So it is dedicated function in the function solution, but in the drawing, you can only see it as this big box that contains all of the individual numbers, because all of the numbered boxes, those are the activity functions which only do one thing. For instance, talking to the GitHub API or talking to Twitter API, things like that. So here's a sample of an orchestration client function. I will show quite a bit of code. It's all in PowerPoint, and it's all based on C#. So if you're not really familiar with C#, you might have some difficulty reading. So I hope it's still clear enough for all of you. So a client function is basically a regular Azure function. So in this case, it's an HTTP triggered function, and we have modified the route parameter so we can specify the orchestrator name that you want to start when we call this function. The runtime knows that this is a client function because we use this durable client attribute here, which gives us access to the durable client interface. And this function will read some input from the request, and we will use that input, and then we will use the durable client interface to start a new orchestrator with the start new async method. That has two arguments. First is the orchestrator name, which we get from the route, and the input, which we read from the request. So note that the return value of this start new async is an instance ID. So it does not give you back the result of the orchestrator, because orchestrators can be long running, and it'd be very weird if you were waiting for an orchestrator result if that orchestrator will be running for days and days. So what you get back is the instance ID of the orchestrator that will start and will do work for you. If you're using the HTTP trigger, there are some built-in methods to get back an HTTP response with some useful information. So that's the create check status response method, and you will pass in the request and the instance ID. What do you get back? That's in the next slide. And it's all a bit slow because my machine is a bit sluggish. So this is the status response, what you get back. So you get back a 202 accepted, and that contains the ID of the instance that has been created, and it contains a couple of links. And the header It also contains one of the links. It's the location header. That contains the link that you can call if you want to check what the status is of the orchestrator. So when you go to that link and the orchestrator is done, you would see the following. You would see this output. So now you get back a 200 OK, and you'll see the content which contains several things. For instance, the instance ID. Again, you'll see that the status of this orchestrator is completed, but it could also be failed, or it could still be running. It could also be terminated if it was terminated by a client before. You can see what was the input of the orchestrator, and you also see the output. So note that you don't necessarily need an orchestrator result. So returning something from an orchestrator is optional. All right. So here's an example from an orchestrator. I'll dive into orchestrators and different patterns a bit more later. But in general, you will use an orchestration trigger to indicate that this is an orchestrator function. Orchestrators are usually started with some input from the client, and the way to retrieve that input is to use the getInput method and then specifying the type, what has been put in. So in this case, we put in a string, so you can read that string back by using getInput of type string. And here we call two different activity functions by using the callActivityAsync method. But again, I'll explain this in a bit more detail in a further slide. And finally, we return the result of this orchestrator. But again, returning a result is optional. So the final function type is an activity function. So that's the smallest unit of work. It's recognized by the framework that's an activity by using this activity trigger. And here you can either use a simple type or a POCO type, or you can use what is called the Durable Activity context. And then you can use that context in the same way as the orchestrator context to read the input. So you can do a get input on that context, but it's usually easier to just use a typed version of this activity trigger. And in this example, I'm just calling out to a different service, which I've injected here, and just returning a result. So this is usually how small activity functions should be ideally. All right. So this is probably the most important slide of the whole thing, because I mentioned that the state of the orchestrator is persisted to storage, and that allows orchestrators to be very long running. But how does this all work under the hood? And I think it's important that before you start working with durable functions, you know a bit more how it works internally. So what we see here is a client function all the way to the left, then an orchestrator function, and that orchestrator function is three activity functions. So below I've made a sketch of table storage. So we will see what is captured to table storage. But the control flow of durable functions is regulated by different queues. So there's a control queue that controls if the orchestrator is running, and there are work queues that control the workloads for the different activities. So what happens when you use the start new async method on a client, then the framework will create a message, put it on a queue that will be picked up, and it will be checkpointed to table storage that we are about to start an orchestrator. So that message is picked up, and the content is read from the message, because that is usually some kind of input that you want for that orchestrator. And then the orchestrator will execute. And before it's actually executed, it returns to the client what instance of the orchestrator is active. Then the orchestrator runs, and when it sees the call activity function, it will use another queue and a message with any input there in order to start it, and also that is checkpointed. So once it sent a message, the orchestrator will go to sleep. It won't be active anymore, and the activity function will start. Once the activity function is done, it will again create a message for the queue with the result. The orchestrator will pick that up again, and then the orchestrator will replay. And that's very important to realize, especially if you're debugging your orchestrator. You will see that the orchestrator will be active a lot of times. So it will always be activated for at least the number of activity calls you have, usually a bit more. So what it will do, it will again check if function A1, so the first activity call, if that has been called. So it will check the table storage, and it will see, yes, function 1 is completed, so I don't need to call that again. So it will then go to the second call. And again, it will use a message to trigger that. Again, that is checkpointed. The next activity call will be active. The orchestrator will go to sleep again. And once the activity is done, another message is used for the result, and the orchestrator becomes active again. So again, it will replay, and it will check first, is my first activity call done? Is my second activity call done? Both are done. So then it will do the other one, which is not done. So again, it uses messages for the control flow. The final activity will then execute. Orchestrator is sleeping again. The result is then put in a message. The orchestrator runs again, but now the orchestrator is complete. So there's quite a lot of things going on under the hood. So quite a lot of messaging is going on, quite a lot of checkpointing is going on. So that's very important to realize, especially if you have a very high load. So what you see here is some screenshots of the table storage. So you can see what kind of things are logged. So you see all the events that are logged. You see the name of the activities in the orchestrators. There's also the actual in and output are also captured. So a lot of stuff is in there. So normally you wouldn't actually need to go to see this. Durable Functions has its own HTTP API and also C# API, which you can use to actually to inspect this history. But maybe in some regular case of debugging, then it might be still convenient to go to the storage and to do some searching here. But for normal usage, you don't really care about how it's stored, but it is important that you know that all the data is in here. All right, so let's talk a bit about different application patterns you can do with orchestrations, because there are quite some. We'll start with function chaining, which is the most basic pattern. You already saw it very briefly when I talked about orchestrations. So chaining is just calling one function to another function in a sequence, and usually you use the output from an earlier function as input for the next function. So conceptually, it's this, F1 to F2 to F3, but in reality, with orchestrators, the activity functions are not aware of each other. Only the orchestrator is aware of all the different activities. So a call is scheduled to the first activity call, it's awaited, so the orchestrator will stop its execution, and then only once it has the result of activity 1, it will continue, and then the second one, and then the second one. So it will respect the sequence that you programmed in the orchestrator function. Well, how does that look like in code? So here's an example of an orchestration, and here we make a call to an activity, and we specify the type, the output type as the generic parameter. So we expect back a type of function 1 result. The two arguments for an activity are the name of the activity and an input argument. Input argument is optional, but you also always need to specify something. So in case you don't have an input argument for an activity, you just need to specify null. Also note that calling or starting orchestrator for calling activities is all based on strings. So it's not really type safe. So you have to be careful with that. There is a ROSM analyzer that comes with Durable Functions. So when you install that, you will get warnings if you have mismatches in the name of the activity that you're trying to call and the real activity name. So you will be warned, but it might be a bit tricky sometimes. So the orchestrator starts, the control will move to this activity. This orchestrator will then stop. And once the result is there, this orchestrator will then replay, and then it will have this function run result, and then it will continue. And then this activity will only be called if the first activity of the result has any details. So this is what is normally done in workflows. You have some if statements, some conditions, and only under certain conditions you'll call some other activities. And again, as I mentioned before, here we specify a return result for the orchestrator, but it's completely optional. To be honest, over the last years, I've hardly ever used results from Orchestrator Functions, because usually you have a result and you either store that result in a database or you call some other API, which means you just have another activity call at the end of your orchestration that performs something. So it is very rare that you actually use an orchestrator result like this. So the next application pattern, well, no, we're still with the activity calls, with the function chaining. But let's say one of the activities is prone to have some performance problems, or is not always available. And when an activity fails, the exception from the activity will bubble up to the orchestrator, and then the orchestrator will fail. And yeah, that's obviously something you want to prevent, especially in case of transient errors. Maybe an API is not available, but a few seconds later it might be available. So there is another method available called call activity which retry async. And then you can provide another argument, and those are retry options. And using this method with retry options, Durable Functions will retry your activity call in case it fails. So it's a very lightweight and easy way to add some resilience to your orchestrator. And you have quite some control over how often do you want to retry it. In this case, it's 3 times every 30 seconds. And you can even specify a backup coefficient, so the times will increase more and more the more often times you retry it, to prevent overloading backend systems. So it's not as advanced as Poly, but again, this is also a lot simpler to use. So I use this all the time, these retry options. Another very useful pattern is called fan out, fan in. And this pattern is used when you want to perform a lot of activity functions, a lot of tasks which are unrelated, but you do want to aggregate some information over it in the end. So you want to do as much as parallel as possible in the beginning, but then each of the activities returns a result, and you want to combine the results. So conceptually, it will look like this. Where are we? So let's say our orchestrator function is called with an array of 100 elements. And for each of the elements in the array, we want to call activity function A1. And we want to capture all of these 100 results. So this is then executed, and it returns. And only once all of those 100 activity calls have been completed, then we call another activity function, and then store that aggregated result, for instance. So the fanning out part is usually very easy. It's also when using other kinds of frameworks or workflows. But the fan-in part is usually quite difficult here, because when do you know that everything is complete before you do something with the aggregated result? So Durable Functions is really good at this and makes it really easy to program this. So in code, it looks like this. So what we have here, if you have a collection of names you want to do something with, what we then first do is we prepare a list of tasks that have the output of the activity we want to perform. So in this case, we have a list of task function one result. Then we will iterate over all of the names in the collection, and we will prepare the task. We will prepare the task for calling the activity function, but we are not awaiting the activity calls here. So the orchestrator is not scheduling them yet. We are purely defining the task and adding the task to a list. So once we have done this iteration, we will have a list of tasks to be executed, and then we instruct the framework to execute this as much in parallel as possible, and we will only continue when all of these tasks are completed. So the result is then available in the function one result, and we can then continue calling the next activity function with that result. You can also see a variation on this. For instance, you maybe want to check some hotel prices, and you have different providers to check for prices. What you can do, for instance, is then do a task when any, and then you only wait until the first one comes back, and then you simply use the first result, which is available, instead of aggregating over everything. So it's a different use case, but you can use this fan-out, fan-in pattern in different ways. All right. And the final pattern I will discuss is the human interaction pattern. For instance, when you need some kind of approval for something, let's say you want to buy something and you need approval from one or more managers. I think many of the workflows in business deal with this situation. And then depending on the outcome of the approval, you then have different paths in your workflow. So let's say people work at a very bureaucratic company, and you need approval of 3 different people. That must be terrible. Then our code will look like this. So there's a method in the orchestration context called wait for external event, and that requires an output type. So in this case, it's a Boolean, and it requires a name of the event. So in this case, we've defined 3 different events, all of the same type, because this is the use case of the 3 different approvers. And this looks a bit like the fan-out, fan-in pattern, because we are just preparing the tasks here, and we are not awaiting them. So these 3 tasks are then combined here, and we will only continue when all of these tasks have been executed. So when all of these events have been received. Then follows the logic of in case everyone approves, then we do the happy flow, and if some did not approve, then we have the unhappy flow. So this could work, but it's still a bit naive, because what happens when one of the approvers is not working for a couple of days because they are on holiday or they are sick? Then this workflow is stuck, and it's stuck until eternity, unless you use a orchestration client to terminate this orchestrator, for instance. But we can do better than this. So there is a variation on this, and with this variation, that allows you to specify a timeout and some default values. So here we see we've defined a timeout of 48 hours, and we use that timeout value as some additional arguments in the wait for external event, and we also provide a default value. So what it means is if we've waited for an external event for 48 hours and we haven't received the event, then the default value of false will be used. So whenever you use the wait for external event, always include a timeout and a default, because otherwise you're probably a bit too optimistic about how workflows are handled. All right, so that was the receiving of events, but of course events has to come from somewhere, so they have to be raised, they have to be sent. So there are various options how you can do that. One of it is using the C# API from a client function. So here we are in an HTTP triggered function, and we specify the instance ID of the orchestrator in the route. That is the tricky part about handling and raising events when it comes to durable functions, because you need to raise an event not only to a specific orchestration, but to a specific instance of an orchestration. So we need to have that instance ID somewhere. So this is a durable client function, so that allows us to interact with an orchestrator. We read the approval information from the request in this case, and then we use the raise event async method to actually raise an event to a specific instance of our orchestrator. So we have used the instance ID. The next thing we need to specify is the event name, and the final argument is then the result. So it's either the true or false. So there's not a lot of code you need to do, but obtaining this instance ID can be tricky. So that's something to be aware of. What I usually do is, as part of the workflow, that I first store this instance ID somewhere, and that can also be done with Durable Functions, or you can store somewhere else. And then at a later stage, when this event needs to be raised, I make sure I can read it instance ID from that state and use it. So an alternative to the C# API is to use the built-in HTTP API. So you don't even have to write all of the code that I've shown you. You can just go to this URL, so this is the root of wherever your function is running. But again, you need to specify the instance ID and also the event name, and then you can specify the type of your event here in the body of the request. So this is available out of the box. So in very simple situations, you can just use this. All right, so that concludes the events. So let's talk about multiple orchestrations now. And so I've shown you what you can do with just one orchestration. But usually when we talk about business processes, it's not very uncommon to have multiple orchestrations. And there are various things we can do with that. There are quite some variations, because we can have orchestrations in one function app, but you can also have orchestrations across multiple function apps. So let's first have a look at orchestrations in one function app. Again, I'm waiting for my slides to change. So before we dive into that, let's briefly highlight how Azure Functions are grouped and how it's working in Azure. So we have a function, for instance, an HTTP triggered function, or it could be other type of function, but that function is encapsulated, that the deployable unit is a function app. And that function app can contain many different functions. And in case of durable functions, it will always contain different functions, because you have a client function, you have an orchestrator function, you have probably some activity functions. So your function app will always probably contain more functions. And you can also have different or multiple client functions and orchestrator functions in one function app. That's also possible. That also works. That's fine. But there are different ways then how you can use different orchestrations within one function app. All right, so let's see one of the two ways how you can do that. So the first way is to start new orchestrations or start multiple orchestrations from one client function. So you have the client function, you do a start new async method, which starts an orchestrator, and that orchestrator uses 3 activity functions. Fine. But in the same client, just one row, one line below that, you can start another orchestrator, which is completely independent of the first orchestrator. In this case, both orchestrators use activity function 3, but just to illustrate that activities can be reused across different orchestrators. But there's no information going from orchestrator 1 to orchestrator 2 or vice versa. So we have 2 independent orchestrators which can be started from one client. So definitely possible. But what if you want to do some orchestrator chaining, for instance? So you first want to run orchestrator 1, and the output of that you want to use in orchestrator 2. Well, that's not possible if you want to do this from one client. But there is a solution for that. And that is to not do it from a client function. Before we dive into that, this is the code sample that belongs to this example from the client still. So this is the client function, HTTP triggered, and we do a start new async on this line, and then we do another start new async. Since this is an HTTP triggered function, you have that check states response method you can use. But it's already quite apparent that this is a bit of an unusual case, because that check states response method only accepts one instance ID to be provided in there to give you back the status. So yeah, this already, it's a bit of a red flag that you're probably not doing something right here. So although it is possible to do it from one client, it's not recommended. Okay. Let's move to the more elegant solution now. The more elegant solution is to use sub-orchestrators. So normally you would have a client function that starts an orchestrator function, and that orchestrator can schedule activities, but orchestrators can also schedule sub-orchestrators. So that's a very nice feature, and that follows the exact same pattern as you do with activity calls. So let's look at the code. So this is an orchestrator function. It first calls an activity function, but here on this line, it's using the call sub-orchestrator, which retry async method. So it's almost the same as with the activity. We specify the output type of this orchestrator. We specify the orchestrator name. We can specify retry options, and there is the input for this orchestrator. So here, this orchestrator, it will call this sub-orchestrator, but then this main orchestrator will stop executing. Once this sub-orchestrator is done, then this main orchestrator will replay, and then it knows that it has this result, and then it will continue scheduling the other sub-orchestrator, where it can use the output from the first sub-orchestrator as input for the next one. So this allows you for some more flexibility. So using the sub-orchestrators is really quite valuable. It allows you to break down one big main orchestrator. So you can have some more code reuse, a bit more, probably easier, more readable orchestrators, which is quite nice. Although you have to be careful not to go overboard on this. And so I wouldn't recommend a main orchestrator and then calling a sub-orchestrator, and that sub-orchestrator calls another sub-orchestrator, and so on and so on. Then your code becomes really hard to navigate. All right, so that was about sub-orchestrators and how to deal with multiple orchestrators within one function app. So now let's have a look at how to use multiple orchestrators across function apps. So it's not, let's say, natively supported to call out to another orchestrator in a different function app using the Durable Functions API. So you have to work around that. So you have to cross this function app boundary, and there are different ways of doing it. And I have three examples how you could do it. So there are many more, but here are just some samples. You could do it via HTTP, you could do it via queues, or via event grid. So I'll cover these in a bit more detail, and then you can decide which way you prefer. So if you go to the HTTP route, we have our orchestrator here that does some activity calls. And then finally, we want to start another orchestrator in another function app. One way we could do it is by making an HTTP call to an HTTP triggered client function. So we specify the URI here, or better, we would read that from an app setting, of course. And we can use the call HTTP async method, and we can do a post to this URI with some result. And this would then trigger another HTTP client. And that client would then start that orchestrator. So that's possible. It's probably the easiest to do. But in general, I prefer to not to do a lot with HTTP stuff, because what if you do when it fails, can you retry it, things like that. So usually I tend to avoid doing this chaining with HTTP, but you can definitely do it. Instead, I would recommend to use queues, and you can use the basic storage queues that also Durable Functions is using under the hood. So if you use queues, one of the things that you could do is add a final activity to your orchestrator. And the responsibility of that final activity is to just push the result that you have to a queue. So in this case, it's a very small activity function and uses the return and a queue attribute to indicate whatever comes in, I just put it straight away on the queue. Right. And then you can have a queue triggered client, Durable client, that listens to the same queue. So that picks up the message and it will then start a new orchestration. And so this is more or less how Durable Functions is also working, because it also uses queues under the hood. But in this case, we are also passing the payload in the message instead of storing it in table storage. And before there was Durable Functions, and most of the function chaining and stuff like that was done via queues, just like this. So I still prefer to do this. It's very reliable. In general, I love use of queues. So I definitely recommend this. A final option to have these multiple orchestrators across apps is to use Event Grid. If my slides are cooperating. These. Yes, there we are. It's really slow. So I'm not sure how well you are known with Event Grid, but it's a really awesome eventing backplane in Azure. Lots of things can communicate with Event Grids, and that list is still growing. So the list of event sources here on the left, this is already, I think, quite outdated. But all of these Azure services can publish information to Event Grid, and you can subscribe to Event Grid and have the event handlers do something with the information that is published to Event Grid. So one of the things that's an event source is Durable Functions, so that can push information to Event Grid, and then you can have another serverless function listen to Event Grid, and then start a new orchestrator. So I do have some samples of that. Let's continue. All right, so there's a publisher side to it and a subscriber side to it. And in this case, Durable Functions framework, they have support for event grid. So there's an event source for Durable Functions, and they have a built-in topic, and that's called the orchestration status. So you can configure Durable Functions, and I'll show you in the next slide how you can configure it. You can configure it to publish information about the orchestration status. So that's published to an event grid topic, and then other applications who are interested in that can subscribe to that topic. And with a subscription always comes an event handler, and that will then pick up that event and can do something with it. So in this case, the event handler can be another orchestration client function. And just as the same way we had the HTTP trigger client or queue trigger client, in this case, it's an event grid client function. It is a bit more involved to configure this, though. You can either do this through the portal. I have some samples how to use the Azure CLI to create this. And this, by the way, it's all documented here, so you can definitely follow yourself if you follow these links. But you need to create an event grid topic, and you need some information from that topic, and you need to then provide that information in your host.json. So you need to extend your configuration of your function app, and you need to provide some information about the event grid. What is the endpoint of the topic? You need to provide a key setting name. I'll show you a bit later why you need to use it. And there is some configuration for your event grid itself, which again can make it more resilient. One of the most important things is what kind of things do you want to publish? So in case we're talking about the orchestration status, in this case, it's only publishing started, pending, failed, and terminated events. But in general, if you want the completed event, you should, of course, put the completed event in here. So next to the host.json configuration, you also need to configure some app settings. So you need to put the event grid key, which you get from the statement. You need to provide it in your app setting, and you need to make sure that this key setting name matches. So that's important information. So that's from the publishing side. So you have that set up, but then you still need to consume them. So then it's about the subscriber side. So the subscriber side is then your event handler. In this case, that's the orchestration client function. In this case, it's an event grid trigger that can start your other orchestration. Again, you need to create this subscription for event grid. So again, this is an Azure CLI command to do it. You can also do it via the portal, and I'm pretty sure that there are other ways of creating this. But you need this because otherwise your function will not be coupled to event grid, so it can't actually respond to it. So you need to specify some information which you got earlier when you created the endpoint. Yeah, and finally, you need to provide what is the name of the function that will handle the event, and again, you need the event grid key, which I've shown earlier. So like I said, it's a bit more configuration to get this working. But again, it's also resilient. I'm not sure if it's more resilient than the queues, but it's definitely more resilient than the HTTP way. So yeah, it's definitely recommended to either use the queues or use the event grid system here. I want to finalize with the KISS principle. I think most of you are familiar with it. There are different variations of it, but I refer to it as keep it simple and small, because Durable Function makes it really easy to create these workflows, and it makes it sometimes too easy. So you can create these huge workflows and huge orchestrators, which call dozens of activities. And I would urge you not to do that. Because the nice thing about Durable Functions is you can actually unit test your orchestrators. Because these activity calls are abstracted away behind interfaces. So you can actually abstract it away and very nicely unit test your orchestrator. But if you have an orchestrator that calls 20 or so different activities, then your unit tests are also becoming quite complex. So yeah, keep your orchestrators, keep them small. That's just very nicely for maintainability. If you have a big one, you can always split it up into different sub-orchestrators. That's definitely an option. But again, if you have an orchestrator and you need to cut it up into 20 different sub-orchestrators, that's also probably a code smell. So maybe there's too much responsibility inside this workflow. So you need to probably then split it up even more, and probably even into different function apps. And then make sure you either use queues or use event grid to communicate between those function apps. And there was one more slide, I think. Yes. The Durable Functions documentation is pretty good. So documentation is there for C# or for Python and for Java. I think also for PowerShell, JavaScript. So it's supported for quite some languages, which is nice. If you want to know more besides the standard documentation, I've got a YouTube channel where I explain a lot about Azure Functions and also Durable Functions. I've also got some Durable Functions challenges, which might indeed trigger you to dive into this a bit deeper. I'm not sure if there are any questions now, so feel free to ask questions now, or also contact me on Twitter. I'm always happy to help with these things.